Sports Cubicle. The hosts, systems analyst Mike Mercado, project manager Devin Tingle, the marvelous one, Dan Marver in accounting, and me, well, it doesn't matter what I do. You can check us out, The Sports Cubicle, Sunday nights at 9 p.m. Central on WCPT 820 Chicago. Gotta go, Sports Cubicle, 9 p.m. Sundays, WCPT.
This is WCPT 820, where facts matter.
You are listening to Think Theory Radio. Hello and welcome to Think Theory Radio, the show that brings you topics outside the mainstream realm of thought and ideas to make you think. And I'm Damian Perdue, your spaced out guide on this oddball ride of radio delights. And of course, I'm joined by Paulie C.
I wish I could do like an alien noise, like yo, yo, yo. Yep.
Or you could do the, you remember the old, I think Sesame Street or Electric Company? The yep. And if that gives you any hint of what today's show is, it's going to be Space Oddities.
Are there any aliens in your Space Oddities?
There's always aliens in my Space Oddities.
Okay. I just figured there might be
No,
teas, maybe?
Not
No?
necessarily aliens, but the possibility of alien life.
Okay. Well, yeah, isn't that always an alien story? That's the same thing.
But I have a bunch of just weird kind of like factoids, strange anomalies, and, you know, different things about the universe that, like, a lot of people don't know. Like, did you know the moon is actually shaped like a lemon?
The moon is shaped like a lemon. Well, I mean, it's got to be somewhat spherical.
Yeah, well, I guess the reason we see it more circular is because of the distance.
Yeah.
So it's kind of like a optical illusion in a sense.
Lemons look like lemons from far away.
But, well, if you looked at a lemon from the top,
Yeah. And so, okay.
it'd look like a circle.
All right. So did they just figure this out after they rounded it and like, well, I'll be? It's got
I think
little...
after the, you know, back in the day when they started getting close to the moon, they actually started saying, oh, whoa, it's a little bulgy. It's not like,
yeah.
I don't think it's like an actual, like,
It's the same when you see lemon
pointy
shapes. It's a little more
lemon.
oval, a little more football shaped than.
Yeah, it's a little basically flattened
Yeah.
at the top
Okay.
and bulgy in the center,
Okay.
which they believe was caused by like the tides and the gravity and everything,
Or maybe
the spins.
eating a little too much during the holidays, probably.
It's all that cheese.
Yeah. Not spinning as fast as it used to.
Yeah. What
All
kind
that cheese, yeah. All that cheese, yeah.
What kind of cheese would the moon be?
I was waiting
if
for
the
you to be
moon
like,
was
'cause
cheese.
you know, like Artemis, they like go behind the moon and they're talking about like, all right, observe everything you see on the dark side of the moon. I'm wondering if it was like they discovered like, it's a little fatter than we thought it was. Maybe the moon's pregnant.
Whose baby is it?
It's got to give birth
What's
to another moon.
Well, maybe it gave birth. We have a third moon or a second moon,
Second moon?
which is just like a little moon, mini moon.
Well, do we? We have a mini moon?
Yeah,
I didn't know that.
I forget what they named it. I think it's just some kind of number.
Mini moon?
Yeah, we
How
got a
am I
little
just
mini
finding
moon.
this out?
But it's we've had it before. This is a new mini moon.
Oh, Earth has several temporal mini moons and quasi moons.
See?
Huh. Well, I'll be. Because these space rocks are only weakly bound, they frequently drift away after a few months to a few decades. Huh. Well, this is
Crazy,
the
right?
AI. But yeah, no, there's a whole thing, claimed moons of Earth.
Yeah.
Huh. I learned
There's
something
also-
new today.
I hope you learn something new on every show.
I do. But I mean, wow, that's a big
I know a lot
one.
of people don't know that.
Yeah.
I mean, they're too small for the naked eye, you know. But if
Yeah.
your telescope or whatever.
Well, that makes sense because you hear about, like, you know, Saturn has like 50 moons or whatever it is, and it's like, well, why not us? Why did we just get one? You know?
exactly.
This makes sense now.
Yeah, and the Jupiter moons and Saturn moons are crazy. You know, 'cause you have like there's
Well, those are huge planets to begin with. So,
Yeah.
yeah, they got to have some, like...
there's one that's Juno, I think it's called, is the moon of Jupiter that's like volcanic, just this hellscape moon.
Just a flying volcano in space.
They believe Titan could be possibly inhabitable.
Okay.
Where we could colonize it. There's also a thing called a moon within a moon That's a moon orbiting a moon. And I guess on the internet they've dubbed it a moon. Also a submoon, moonitos. Grand moons, moonettes, and moons are the names that have been given to this.
Oh my gosh, like a cow, like moons.
Yeah, exactly.
Yeah.
It's like the cow jumped over the moon. See?
Yeah, okay.
All ties together.
Oh my goodness. Did you expect this to go this path?
I hoped it did. I hoped it would, and it did. Did you know that the Milky Way smells of rum, raspberries, and booze?
What? How?
Because, there's just
Wait,
a lot of alcoholic aliens out there.
You said rum, raspberries, and booze? Is that what you said? Well, what's rum if it's not booze?
Well, there's like...
Other booze?
Yeah.
So it's like just a big
alcohol.
old raspberry cocktail, the Milky Way.
Delicious.
Mm-hmm. Especially on a summer day.
Right?
Yeah.
I guess in 2009...
Summer in space.
Oh, computer went. Oh, there we go.
The whole show's gone.
I know. Deleted. In 2009, astronomers exploring a giant cloud of gas and dust at the center of the Milky Way made this surprise discovery that the cloud was packed full of a chemical known as ethyl formate, which has a couple of intriguing properties. That's what's responsible for giving raspberries their flavor and has the smell of rum. Another nearby region is full of ethyl alcohol, or ethanol, the type we use to make alcoholic beverages. And check this out. It contains enough alcohol to supply everyone on Earth with 300,000 pints of beer per day for 1 billion years.
I still feel like Chicago or maybe Scottish soccer fans could handle that.
Yeah.
Yeah.
Diverging a little bit, but did you see that White Sox fans we are the number one
still
drinkers?
Usually every year when there's that survey, usually it's like White Sox fans are the biggest drinkers in the MLB. Yeah. All right, we did it again, boys.
Did it again. I feel like I should have read that one. Everyone on Earth, 300,000 pints of beer. If bottled this source, the proof for this beer would be kind of low with just an alcohol content of less than 1%. So I don't know. Why?
Yeah.
Okay, but why? So if you're going to give 300,000 pints of beer that's only 1% beer, why not just give everyone 50,000 pints
of 2% beer?
of 3% or 5% beer,
Maybe, yeah.
Come on. I'm on 1% beer. What's the point?
What is 1% beer? Sounds like an accident.
Mm-hmm. Exactly. And what I was thinking about was Voyager.
Star
That's
Trek?
kind of yes, that was a classic show. Very
No,
good.
you're talking about the actual orbiter,
Because that's kind of like a weird oddity, in space.
The probe Voyager is what would you call
Voyager 1.
Yeah.
There's Voyager 1, there's Voyager 2.
What would you call it? A probe? What is it?
Yeah, it's a probe.
Yeah.
Mm-hmm. And it's 50 years old. I guess earlier this year they powered down an instrument on Voyager to keep it alive. And it's I guess it's running critically low on energy, and that forced NASA to make these sacrifices. But it's continuing to send back unique data from beyond our solar system. And then I looked up, I found that it's another little interesting thing about Voyager 1. So right now it's crossing interstellar space, which is amazing when you think about this, low-tech probe built 50 years ago has traveled beyond anywhere, you know what I mean? And this thing has been running with just 6 computers holding about 68 kilobytes of memory. So that's less storage than a single compressed photograph on a modern phone.
Wow. How far we've come.
That's pretty wild. And that it's still sending data back. And I mean, it's still, even though they have to shut down some certain things and there's been little, problems here and there, but they've been able to restart it and get info. And it's amazing, that one, how low tech it is and it's still surviving. But when you think about if it made it somewhere where there was, another advanced civilization.
Yeah.
Imagine what would they like? Would they look at this and be like, who made this thing? Is this from, cave people? Who made this low tech thing? But it's still out there, surviving the vacuum of space. And let's see what else we got. A little more space facts. Space facts. Oh, this one's crazy because Mercury, a day is twice as long as a year.
Like, wait, a day is twice. Hold on, a day is twice as long because it orbits so quickly around the sun, or something.
Yeah, it's because the way it spins and how fast it goes around the sun.
Because it probably also spins slow, like the
Or fast, I think.
No, because
slow.
Slow, yeah. Like so, Jupiter. I think a day on Jupiter is like really quickly because it's spinning like super fast.
Right.
Yeah,
that makes sense. Yeah, because it says one Mercurian day lasts 59 Earth days.
There you go.
While a year lasts 88.
Yeah.
So that's pretty crazy. It says, due to Mercury's very eccentric orbit and alignment with the sun, the length of time from sunrise to sunrise, known as the solar day, is equal to 176 Earth days, twice as long as a Mercurian year.
Wow. Okay.
That's a wild kind of mathematical conundrum.
Okay.
You know, when you just hear the numbers, like it doesn't make sense.
Mm-hmm.
What?
And well, because we all know it relative to Earth, and it only makes sense, you know, with Earth, because that's our entire lives is based on that. So I'd imagine that it's just kind of a hard thing to conceive, you know, like the concept of just like a very slow moving planet, and that it like coincides with its orbit with the sun as well.
Yeah.
But you're saying sunrise to sunrise, so I'm wondering if like, is that because of where it's at in the year and its spin? It's like that part doesn't see the sun for that long. Yeah, I don't know.
It's trippy though.
We'll never know.
Well, I know like Pluto, I think it's some crazy amount. One year there is like 10,000 Earth days or something like that.
Oh yeah, what, like one orbit of the sun or whatever? Yeah, yeah.
And still to keep it within the solar system, all the other planets in the solar system could fit between Earth and the Moon if you lined them up side by side.
Yeah,
that's pretty wild. I guess that's not that wild. Planets aren't. I mean, Jupiter's pretty big, but the rest of them aren't that big.
Yeah, and we line them all, and then the Moon's pretty far away.
Exactly. And in case you were worried about it, Paul, you could survive a couple of minutes in a leaky spacesuit.
Couple of minutes. Okay.
It's not immediate. You're not going to blow up or freeze immediately.
Time to think about my impending death. That's reassuring.
Well, you watch a lot of sci-fi movies. They get chucked out into space. They immediately
blow up. Yeah.
You actually.
It's like my head won't like implode, or my like eyes won't get sucked out of my head, or.
Well, I guess so.
After all the air will leave my body immediately, and then I'll just be like brain dead a few minutes later, right?
Well, you would have only about 10 seconds before you lose consciousness.
Yeah.
Which is kind of good because you'd be passed out when your body explodes or
that's reassuring.
The lower pressure of the vacuum would cause your blood to boil, along with other body fluids, like the moisture in your tongue and saliva and stuff like that. But the boiling alone would not be fatal due to the pressure maintained by our blood vessels themselves. Gas bubbles would form in your bodily fluids, causing your body to swell up and bloat. The low humidity of space would cause you to cool down rapidly, and your eyes may freeze over. Within 1 to 2 minutes, the lack of oxygen would be deadly. And that's when you die.
And there you have it. I got all the how long is a day on each planet in front of me. So, Earth, obviously 24 hours, but I didn't realize Mars is like slightly longer than Earth. It's 25 hours or 24 hours, 37 minutes. All of them are like relatively like a day. Like Venus is the only one that has its day longer than its year. So, so like you're saying, Mercury is like 58.7 Earth days is a year. Venus is 243 Earth days is a year. But Mercury's a 1,408 hour day. And Venus is a 5,832 hour day. Mars 25, Jupiter 10 hours, Saturn 11 hours, Uranus 17 hours, Neptune 16. Yeah.
I think it's Uranus is the only one.
I thought you were going to say it's Uranus and just correct me. No.
No, I'm not. That was too easy, Paul.
Yeah,
Too easy.
Just waiting for that.
But I forget if it's that one. Maybe you can look it up. It's either that one or Venus is the only one that rotates clockwise. Like all the other planets rotate counterclockwise.
I know what you mean, yeah.
There is did you know that not only the Milky Way has like, raspberry and rum flavors, there's nuclear pasta in space.
Nuclear pasta. Okay.
Delicious.
Venus and Uranus, by the way, are the clockwise. Yeah.
See, I was right. I thought it was only one of them, but I guess there is one. See, nuclear pasta, man.
Well, okay,
good,
and then
arrabbiata sauce.
Uranus also rotates on its side.
But what's a side in space, man? There's no sides in space.
Well, relative to us, maybe.
Yeah.
I don't know. That's a good question.
Yeah. It's like, there's no north and south, man. It's all an illusion that they tell us to keep us controlled.
They might think you rotate sideways.
It's true. I do sometimes after drinking too much of that space rum.
That raspberry space rum.
But there's the strongest substance in the universe forms from the leftovers of a dead star.
Okay.
And according to simulations, protons and neutrons in a star's shriveled husk can be subject to insane gravitational pressure, which squeezes them into linguine-like tangles of material that would snap, but only if you applied them 10 billion times the force needed to shatter steel. They call that nuclear pasta. I don't know why, but sounded kind of interesting.
Nuclear pasta.
1 tablespoon. Oh, no, teaspoon.
Okay.
Even smaller. 1 teaspoon of neutron star weighs the same as the human population.
1 teaspoon.
1 teaspoon. If you had a little teaspoon of a neutron star,
Yeah.
you cannot hold it because it weighs more than all the people on Earth.
Wow.
Mm-hmm. That's because the density is mind-boggling.
It's got to be a strong spoon to hold all that.
Mm-hmm. What kind of spoon would that be? Isn't there like a you could use the
infinity spoon? I don't know.
Big Dipper.
The big there you go. There you go. You don't even need all that though. You'd barely see it in that dipper.
That's true. You use a little dipper.
You need the little Yeah. Yeah. Still a little big, but okay.
And that's because these kind of stars are composed almost entirely of neutrons packed together in a tiny radius. And that teaspoon would weigh over 1 trillion kilograms, which I guess the entire human population is about a few 100 billion kilograms. So we're not as fat as we thought we were. Let's see. Gamma ray bursts release more energy in 10 seconds than our sun in its entire life.
Okay. A gamma ray burst.
Gamma ray burst. That's that's what gave the Hulk its powers.
Okay.
Gamma rays.
For real though, what is a gamma ray?
It's a high flash of high energy radiation.
Okay. And that has more than a star or more than the sun has in its
in its entire life.
Wow.
Now there are many different types of gamma ray bursts. Some are thought to form when massive star implodes, other when 2 neutron stars, like we just talked about the neutron, merge together and have a little gamma ray burst baby.
Aw.
Let's see what else. Oh, you know what? Let's take a break because I'm going to come back. I want to talk about one of my favorite things. What is a Dyson sphere? And have they found evidence of any in our galaxy? Think Theory Radio right after this.
Let's face it, most of the email you get stinks. You have to fill out some form, or a package is delayed, or a candidate you never heard of is asking for $5. But Heartland Signal has a newsletter, Radio Free America, that will actually make you want to open your inbox. Written by our senior political analyst, that's me by the way, we focus on the stories springing up from the states before it gets on the Beltway media's radar. That means you know tomorrow's news stories today. We try to keep it interesting. We all know the president's a bad guy, so we don't dwell on him too much. Rather, we focus on ways to address the root cause of Trumpism, like how John Ossoff figured out how to address corruption, or what state-level Democrats can do to stop gerrymandering, and why you don't have to worry about Spencer Pratt being the next Trump. And we try to keep it light, too, because let's face it, you deserve a laugh. We never share or sell your email address, and you can unsubscribe at any time. Sign up now at heartlandsignal.com/newsletter.
You're listening to WCPT 820 because facts matter.
Welcome back to Think Theory Radio. This is Damien, and today we're talking about space oddities, which is also almost the name of a pretty good song by David Bowie, Space Oddity.
Space Oddity, yeah.
So, what is a Dyson sphere?
Yeah, what is a Dyson sphere?
Well, it could possibly be an alien megastructure.
What?
So the theory that Freeman Dyson came up with back in 1960 is that if an alien or an advanced civilization, extraterrestrial, another planet, whatever, alien, whatever term you want to use, is advanced enough, far beyond us, you'd get to the point, because you have to consume a lot of energy. And at a certain point in the advancement of civilization, we would stop using fossil fuels, people, and start utilizing the power of our sun or the star. Mm-hmm. And you would build either a massive structure around the star or some kind of satellite grid system that could harness that star's energy, that sun's energy, and focus it towards the planet where the civilization is. Okay. So scientists, astronomers, astrophysicists believe that this is one way to be able to detect an alien civilization, is to search for signatures of a Dyson sphere. So I was curious because I love the concept, and there's been times where you read an article and says, oh, yeah, this planet, there's one called Tabby Star, which kind of made headlines because it had a lot of the key details that would be for a Dyson sphere. And so I think, well, how many, exoplanets in other solar systems and stars have astronomers believe or conceive that there could be a Dyson sphere? So far right now, there's 7 stars in our galaxy that possibly could be have a Dyson sphere.
Okay.
And I was wondering, well, how would they know?
Yeah.
Right? How would they know?
How would they know?
So basically what they do is they search for infrared excess, which occurs when surrounding material absorbs light from a star and re-emits it as heat, causing astronomers to see more infrared light coming from a star than they would expect from the star itself. Now, this could be evidence of alien technology or something more natural if it's just clouds, dust, something like that blocking the sun. There's a project called Project Hephaestus, which found 7 infrared excess candidates that were all M dwarfs or red dwarfs, the most common type of star in the universe. These candidates are relatively close to Earth, less than 1,000 light years away, and their infrared light, many times brighter than expected, is compatible with the author's Dyson sphere models. And the second paper, this is from Dr. Frank Marchus. He was a senior planetary astronomer and director of citizen science at the SETI Institute, is using a different methodology and search radius, finding 53 candidates with extreme infrared excess. Now, this could be caused by other phenomenon like circumstellar disks, which is debris left over from planetary formation, like our asteroid and the Kuiper belts, or background objects like galaxies that emit infrared light. But now that we have the James Webb Space Telescope, we should be able to identify more complex things like artificial materials, confirm or rule out background galaxies, and provide more information about the candidates. The Allen Telescope Array also could observe the stars and look for anomalous radio signals that might indicate an advanced civilization. And then this is an interesting one that I never thought of. Laser SETI, which is another project in the search for extraterrestrial intelligence, is also being used to search for these candidates. Laser SETI looks for monochromatic laser light, which does not occur in nature, and that would be a potential sign of advanced civilization. Laser SETI stations are being built to cover the entire northern sky and could detect those Dyson sphere builders. So I thought that was pretty interesting. If you wanted, there is a video online you can check out. Have we really detected Dyson spheres? It's on the SETI Institute YouTube channel. So yeah, like that's one thing I always see when I see something about Dyson spheres. And also I think, why are we not, are we here yet on Earth? Can we get to the point instead of all these satellites around our planet? Why don't we figure out a way to put the satellites around the sun?
Mm-hmm.
But we're probably not there. Probably not there yet. Talking about satellites and also things in our orbit, because remember we did a show about junk, space junk, all that junk.
Yep.
Well, unfortunately, astronomers have found a hidden swarm of space junk.
Uh-oh.
Threatening Earth's most valuable orbit, which is the Earth's geosynchronous orbit, and holds some of the most valuable satellites that carry out tasks for our phones, television and radio, as well as weather, environmental monitoring, government spy agencies, military tech. And so the new study published in the Journal of Astronautical Sciences, astronomers re-examined an archival data set from a previous survey of debris in geosynchronous orbit using the Isaac Newton telescope in La Palma, Canary Islands. And by processing the images using newly developed algorithms, the team behind the study found 25 previously missed debris tracks. Debris in the neighborhood of the geostationary belt is particularly concerning, James Blake, research fellow at Warwick Center for Space Domain Awareness and lead author of the study, said. It's very far away, well above the Earth's atmosphere, so small objects tend to be incredibly faint and difficult to detect, and any debris that's generated will stick around indefinitely. Nearly 80% of the faint objects found in the study were generated by previously undocumented incidents, which highlights the need for a more thorough survey of geodebris. The debris in geosynchronous orbit is a potential minefield, Stuart Eves, space consultant at SGE Space Limited and co-author of the study, said. No one in their right mind would enter a terrestrial minefield without a mine detector. Similarly, no one in their right mind should launch a satellite to geo without an adequate debris survey. And the team behind the new study was able to detect the tiny space debris using a blind stacking technique. This new method has the potential to improve the sensitivity limit of observational data sets to detect faint objects in space. It involves testing many potential paths in an image sequence along with hidden targets might be moving and stacking the images to help bring those targets above the noise floor, they say. This project shows a successful real-world application of the method. Any data set containing linearly moving targets is an applicable use case. So it's kind of wild that doesn't happen all the time. When you think about how much little pieces and chunks of old satellites, the space stations, all the rockets that have been launched or blown up, that we don't hear about satellites getting hit all the time or ripped all the time. You did hear, I think there was something recently with on the ISS, on the International Space Station, where they believe a little piece of something hit, caused a little hole, and they had to repair it. There was this big, it kind of became kind of an international incident because the cosmonauts were basically we're gonna we're gonna torch this thing, like we're gonna. And the NASA, astronauts are like, oh no, I don't think you should do that. Like they're like, no, we're just gonna do it. We don't care what you think. And they so the NASA astronauts cut themselves off, like they sealed themselves in their part of the station. They're like, man, you guys are, you're gonna like cause some kind of implosion or something. We're gonna hide over here and waited it out, but luckily it didn't happen. And they're all still alive for now.
For now.
Let's see. Jupiter's magnetic field is bigger than the moon.
I could believe that. Yeah.
You would think it's pretty. Jupiter. Jupiter's gravity is so great that if it wasn't for Jupiter being in our solar system, the asteroid belt would have destroyed us already.
Yeah.
Mm-hmm.
Yeah.
And so that's a kind of a serendipitous thing with Jupiter being in our solar system.
Everything's, for a reason. We got here for a reason.
Yeah. What's the reason?
It's like Jupiter, several things.
All
Jupiter,
things things have happened for me to have to not be able to pay rent. What the hell?
It gives you ideas for the show, though.
Yeah, it's true. True.
You wouldn't have Think Theory Radio if it wasn't for all these things.
That is true.
Never thought about that, did you?
Should we go to a phone call?
Yeah, let's do it.
All right. We have Armstrong calling in. You are on the line.
Hello.
Hello, who's this?
Hello.
Hello.
This is Mike.
Hey, Mike. How's it going?
Good. Your talk is great, and it reminded me of an article I read about a company called Reflect Orbital. Have you heard of that?
No. What was the first name? I couldn't hear.
Reflect Orbital.
Reflect Orbital? No,
Orbital?
I haven't heard of that.
So they're a startup, and their plan is to launch, I think, 5,000 satellites into space to reflect the sun to the dark side of the Earth to power solar panels.
Oh yeah, I did. I didn't know that was the name of the company, but I did. I know.
And what could go wrong?
Yeah. Well, and I saw that. I don't know if this is the same project, but I saw a quick video of the guy talking, and he's saying, yeah, like you can have an app on your phone where you say, oh, I need some light. Like if you're out camping and then I need some light, and it would turn the mirror towards you and reflect the sun down.
That's
in the middle of the forest or something.
Insane.
Yeah, it is pretty. I mean, I know.
Little
well, it's
excessive.
like Bill Gates had that plan to like block out the sun.
Right.
It's like how
On
many?
The Simpsons?
Exactly.
Anyway, I thought I'd mention that.
No, I appreciate that.
Crazy.
Yeah, that is crazy, man. Like, and the fact that they're getting money to do it, and no one's saying, I don't know, like maybe that's not a good idea,
right? Yeah.
And I know China has a similar project too. So what is it going to be like in 50 years? There's just going to be all these space mirrors, like you're not even going to be able to see.
I know the space is the Wild West, and billionaires just shoot whatever they want up there.
Oh, I know. And the whole like it's going to be more and more with these. They're like creating technology that can grab onto other satellites and mess with them. There's going to be space wars, man. It's coming. It's coming.
Yeah. All right. Well, I enjoy the show. So
appreciate it, man. Yeah, thanks for bringing that up.
Mike.
That's another crazy one. Space mirrors. Why do we need that?
It seems so decadent. Like you're camping. So I just need a little light over here.
Right.
Move the sun over.
I could see if it was something, where it was necessary for a region that like gets no sun, and in order for them to grow crops or something like this, like it was necessary for survival of this place, then yes. But I don't. Where would that exist?
I don't know.
There's nowhere on Earth that doesn't really.
Well, it just seems like
sun.
What if someone takes control of the mirrors and concentrates them on one region, and then it's like cooks the region,
right? Like a magnifying glass,
like over an ant or something. Yeah.
Oh my god!
An intense beam of light just cooking people.
Yeah. Space lasers.
Yeah.
Yeah. You know what's crazy is that
Does that count as a space laser?
they're actually so that here's the messed up thing. So that of course that was like the crazy the Jewish space lasers. Yeah.
Yeah.
But the IDF is actually trying to create lasers so they could shoot from space.
Are you saying that Marjorie Taylor Greene was correct? Is that what you're trying to say?
No, I'm trying to say that maybe she gave them an idea that's going to be
Hey, she's
horrible.
right.
Yeah. Oh, that's a good idea. Thanks.
They're already scapegoating us anyway. We
Right.
might as-
Right. Oh my God. All right, let's go to another phone call. We got Jack. What's going on, Jack?
Damian.
Hello.
Paulie, good to talk. Good to speak with you guys. Love your show.
Thank you. Appreciate it.
I grew up in the Chicago area. I live in San Diego. I'm going to reference what you just said about Jupiter kind of holding our solar system in place.
Yeah.
And of course, the sun does that. And I've heard that if the sun was yanked away, we would immediately go careening off into wherever.
Yeah.
So aren't gravity waves way faster than the speed of light? I mean, I know they use that to calculate other things, but it's obvious. I mean, even if you yank the sun out, it would take 8.5 minutes or whatever for the sun to reach the Earth. So, I guess physicists probably talk about this, but I mean, it's obviously faster and stronger than light or whatever.
From what I know, it's not because I think it's more along the lines of a wave field than kind of the way the photon particles travel.
Right.
So
you got to be smart to figure this stuff out. But
well, it's kind of like
thinking about.
Oh yeah, no, I love that. So it's like quantum entanglement, right? Where you would where they react at the same time. You would think would be faster than the speed of light, but physicists say it's not because it's actually it's more of a connection than a travel of information. If that makes sense.
I see.
Yeah.
Well, I love all the different topics you cover, from the paranormal to the extra normal or what. This is the whole gamut, and I think that's great. And you do it in a professional yet, humorous or lighthearted way. You're not,
I try
down in your seriousness.
Well, thanks. I appreciate that.
Yeah, you guys are doing great. Wanted to wish you well and check in.
Yeah. Well, thanks, man.
Yeah, thank you.
Call in anytime. And enjoy the weather in sunny San Diego.
So, quick internet search, gravity travels at the speed of light. And I guess that's all kind of handled with like Einstein's theory of relativity.
Yeah.
Yeah.
Okay. So it's
and a very rough sort of one sentence sort of explanation of it.
Yeah, I know it's slightly different in the way it operates. I mean, it is very fast, but as far as we know, it's still speed of light is still the top dog in terms
the constant, the fastest. Yeah. But I guess this was saying that gravity travels as fast as the speed of light. Like it's similar, I guess.
It's similar, but I think it's fractionary. I don't think it's as fast. Double check that.
Check. I mean, how do you test gravity's speed? Speed of gravity. Okay. Classical theories of gravitation, the changes in gravitational field propagate a change in the distribution of energy or momentum of matter results in subsequent alteration at a distance of the gravitational field which it produces. In the relativistic sense, the speed of gravity refers to the speed of a gravitational wave, which is predicted by general relativity and confirmed by observation of the GW1708817 neutron star merger is equal to the speed of light.
Okay, but I think
and this
that's in a kind of mathematical way. But
from Hughes, S.A. Flanagan, E.E.'s, or no, S.A. Hughes and E.E. Flanagan's The Basic of the Gravitational Wave Theory.
Yeah. It's wild.
I got through high school physics.
That's pretty good,
I wouldn't have to do this anymore.
It's good, man. You're opening up new neural pathways in your brain.
Yeah.
Putting new information in there.
And now I forgot who won the World Series in 1952.
Now, does a baseball travel at the, there's a fastball, check this out. We're talking about the planets, Jupiter and Uranus, Venus, but Neptune has only completed one orbit since its discovery.
That sounds about right.
Yeah, it takes a whopping 165 years to complete one full orbit around the sun. And since it was discovered in 1846, it's only finished its first full post-discovery orbit in 2011. And Pluto, remember I was way off when I said how long a day on Pluto is. Or maybe I don't know. I can't do the math on that.
Does it even count anymore?
I know. It got demoted.
We're going to talk about dwarf planets now.
Planet.
Yeah. What's so special about Pluto?
But it hasn't even completed one full 248-year orbit since its discovery in 1930.
That's crazy.
Right? And there's another dwarf. I think it's considered a dwarf planet. Or was that one I added about Haumea, I think it's called. Have you ever heard of this?
No.
Hold on, I'm trying to hear it. Haumea, 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 and that's another dwarf planet which orbits in the Kuiper Belt out beyond Neptune. And it has a strange elongated shape.
Okay. It's like not
a lemon.
Yeah.
Maybe more like a watermelon.
Okay.
It has 2 moons and a day that lasts only 4 hours.
Huh. That's a fast turn.
Man, talk about how you would get old so fast on that planet.
You'd probably be very dizzy.
Imagine like coming from that planet to Earth. Like I don't think you
I'd
could
probably get
survive.
like seasick or like, everything would be so slow, I guess. I don't know. Yeah.
Or would you be like super fast or be like Superman? Because then you would, everyone looks like they're moving slow and you're just like, come on, guys, let's go.
I'm going to go visit Earth for a week and it's like 5 years to them.
Yeah. And that makes it the fastest spinning large object in the solar system. In 2017, it got even weirder when astronomers watched it pass in front of a star and noticed extremely thin rings orbiting around it. And they believe that could be the result of a collision sometime in the distant past. So not only is it a mini little dwarf planet that has 2 moons, but it has rings like Saturn. Amazing. Let's see what else do we got here. What do we got? You know what? Let's take a break. We'll take a quick break, and we will come back with more Space Oddities on Think Theory Radio right after this.
Out Chicago.
Kiddos, we all need to find the courage to stand up to people when they say things that are completely wrong. Like what Governor Pritzker said, we need to get ready. When they sound that 5-alarm fire, we all need to be up there with buckets to douse the flames.
I'm ready.
I am too.
Are you?
This flamer is ready to douse the flame, and I never like to douse my flame.
Catch Out Chicago every Sunday, 11 to 1 on WCPT 820. Alexa, play WCPT.
WCPT from TuneIn.
Welcome back to Think Theory Radio. This is Damien, and today we're talking about all the weird anomalies in space. Well, I mean, all of them, but a lot of them. Many of them. And I was reading this article that I found very interesting on earth.com, and it says, is the universe spinning?
The universe?
Yeah.
Oh, man. That's a lot of spinning then.
Yeah.
The Earth is spinning.
The Earth's spinning. The
universe-
solar system spins.
Solar system spins.
That's one of the wildest things
I
to
drink
me.
too much, I spin.
If I hit the herb a little bit too hard, stand up quickly, I'd spin it.
Keep a foot off the bed, you know?
My favorite record spin.
Yeah.
There's also a golden record in space on Voyager 1. So it all ties together. Or is it Voyager 2? I don't know. It's not one of those. But it makes sense, though, when you think about everything is spinning, there, and in the spiral formations. And I did a whole show on spirals before. And how the kind of spiral movement of not only the solar system, but also our DNA and all the different galaxies. And you have the kind of the Fibonacci spiral and how that correlates to mathematics. But is the universe a spiral? Dun, 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 dun. And so nearly a century ago, astronomers proposed that we might be seeing only half of the story of the universe expansion. A lesser-known concept called the tired light theory proposed that photons could lose energy as they travel through space, causing what looks like expanded motion. Some experts have speculated that a possible spin of the universe could influence our perception of cosmic movement. Now, according to most of the experts, they still support the Big Bang model, citing observations of galaxies moving away from us at rapid speeds. But Lior Shamir, an associate professor at Kansas State University, has brought this old theory back into the game. His recent work suggests that a fresh look at the James Webb images might offer a different perspective on what we perceive as the expansion of the universe. Scientists have noted the JWST observations reveal galaxies that seem older than the universe itself, if based on traditional timelines, which this contradicts the idea that everything condensed from a single point. The JWST provided deep images of the early universe, but instead of showing an infant early universe, it showed large and mature galaxies, said Professor Shamir. Big Bang supporters are still not convinced to abandon their view, but some of the astronomy community feels that this data calls for a second glance. The tired light theory was largely neglected as astronomers adopted the Big Bang theory as the consensus model, explained Professor Shamir, and he has offered fresh evidence supporting the long-dismissed concept. If photons gradually lose energy, the universal timeline we use might be off. That helps explain why galaxies appear so developed at early stages. Light might not always be a perfect gauge of distance if it changes subtly on the way. Recent data shows that almost all galaxies in the early universe displayed by JWST appear to rotate in the same direction. Shamir's analysis found up to 50% more galaxies swirling one way, a difference that can be even seen by non-experts scanning the images. He suggests this anomaly could mean the universe was born spinning, or that we might live inside a colossal black hole. That's wild right there. I think the whole universe is inside a massive black hole. Professor Shamir also noted that this rotational imbalance might be due to the Earth's own motion. Because of rotational velocity, galaxies moving the opposite way relative to the Milky Way may appear brighter, so we see more of them. Shamir's team measured redshift in over 30,000 galaxies and found that the gap becomes larger at greater distances. The axis of evil in cosmology refers to unexpected alignments in the cosmic microwave background, or CMB radiation, suggesting a preferred direction in the universe. Now, this is at odds with the widely accepted cosmological principle. Some researchers speculate that this alignment could be a statistical fluke, an artifact of our observational models, or even an indication of new physics beyond the standard model of cosmology. Another theory entertains the possibility of a holographic universe, pointing out that if the universe does have a giant spin, it is not unlike a black hole's interior. Now, this is referred to as black hole cosmology and has circulated in physics for years, and Professor Shamir's research brings it back into focus. His work also suggests that measurements of galaxies have overlooked the Milky Way's rotational speed. If galaxies rotating opposite to the Milky Way show stronger brightness due to the Doppler effect, the difference could alter assumptions about how far away they are. So that's pretty wild. Now, if that holds up, we might have to recalibrate large portions of existing data, which could reconcile other mysteries, such as the mismatch in expansion rates and sightings of hefty galaxies in early epochs. And this will be, we're going to get more and more data from the JWST, the Chandra X-ray, all these other, the Allen telescope. And if they build that telescope on the moon, we should be getting more and more information about the early stages of the universe. But this is an interesting one. And to me, I don't know, it kind of makes sense if I think about how everything else has a spin. I mean, not everything in the universe is spinning, but planets, the sun, solar system, the galaxy itself. I mean, if you look at all the pictures of the galaxies with spiral arms, you could posit that the universe itself is spinning in some strange kind of spiral. Now, here's another one that I find very, very fascinating because, I love the panspermia hypothesis that life originated from outside our solar system and was brought here on an asteroid. And scientists examining samples returned from asteroid Bennu found ribose and glucose inside. And with phosphate and every RNA nucleobase already detected in the same asteroid material, every chemical component needed to build RNA was present in the early solar system long before life existed on Earth. And it's pretty interesting because the sample that they've gotten from Bennu, and that's the one where they actually sent the OSIRIS-REx probe, landed on this asteroid, collected material, brought it back, and they keep finding more and more evidence of different remarkable materials and, bioessential sugars. You got the, like I said, ribose, glucose. They've found lexcose, xylose, arabinose, galactose, and all the other noses and oses and toses. The same paper notes that early Bennu work had already found canonical nucleobases in phosphate, and this one set of sample analysis is not proof that RNA formed on Bennu and not evidence that life existed there. It's more specific than that. It shows that the raw molecular pieces used by life on Earth could be made and preserved in small bodies before Earth had life at all. And Bennu is a carbon-rich near-Earth asteroid, but the material returned from it is not just any asteroid dust. When OSIRIS-REx returned the collected surface material from Bennu in October 2020, delivered to Earth on September 24th, 2023, it describes it as the first U.S. mission to collect a sample from an asteroid and return it to Earth, which is pretty amazing. The distinction between a return sample and a meteorite matters because meteorites, while they pass through Earth's atmosphere and land in an uncontrolled environment, may actually, grab and attach material that already existed here on Earth or in the atmosphere. This is collected from the asteroid itself, so what they have found there has been, messed with by Earth itself. RNA now is built from three kinds of parts: sugar, phosphate, and nucleobases. Ribose forms the sugar in the RNA's sugar-phosphate backbone. The nucleobases carry genetic information. In RNA, those bases are adenine, cytosine, guanine, and uracil. The reason this Bennu result drew attention is that it fills that gap. A 2025 Nature Astronomy paper led by Daniel Glavin reported abundant ammonia and nitrogen-rich soluble organic matter in Bennu samples, including all 5 nucleobases found in DNA and RNA, as well as amino acids and many other nitrogen-bearing compounds. Which is, it's just amazing. And then the other one I was reading about too is one of the craziest things they found on there was tryptophan. They found tryptophan on the asteroid Bennu, and now tryptophan is one of the most essential amino acids to form building blocks of life. But not only that, tryptophan is the precursor to all the psychedelics. This is the precursor to psilocybin. So not only it's possible that the elements necessary for life is found on Bennu, but also the origins of psychedelic compounds. Gotta love it. Psychedelics from space kind of makes a lot of sense to me. All right, let's see if we can crack a couple little more weird space facts in here before the show ends. What else do we got? Of course, I think everyone knows there are stars that we'll never be able to see. I didn't mention the Jupiter. Let's see. Planets can wander through space without a parent star. The rogue planets. And astronomers estimate that there could be more than 200 billion of them floating free and drifting through our galaxy. These rogue planets were thought to have been kicked out of their home systems. And while this is true for some, other planets may have formed completely independent of an accretion disk, instead of forming from the collapse of tiny cold clouds known as globulates. Imagine if a rogue planet just drifted through. That's the conspiracy theory about Nibiru and the Anunnaki would have been like a rogue planet that's came through our solar system, smashed into the planet Tiamat, created the asteroid belt, and then the Anunnaki landed on Earth. Yeah, it's a little fun little myth. Oh, we had the caller when Jack was mentioning the planets drifting and stuff like that. It made me, or the sun moving, and then we Earth would be knocked out of orbit. There's actually a sci-fi movie. I'm trying to find the name of it, but it's about it. They turn Earth into like a spaceship because it gets I think exactly that situation. It's called The Wandering Earth. Okay, and it's actually pretty good. So the sun, actually in this one, the sun is dying out. That's what happens, and they basically like, well, what are we gonna do if the sun's dying out? You know, the Earth's gonna just freeze and we all die.
Yeah.
Right. So they figure out a way to turn Earth itself into a massive spaceship and travel it through the galaxy to find another star to orbit around. And it's, well, at the time, and it was in 2019, it was the biggest budget movie made out of China ever. So it's the special effects are amazing. And it's pretty crazy. You're like, it becomes this whole thing where everyone has to live inside the Earth because you can't live on the surface of the Earth anymore if we're traveling through space. It's just a frozen tundra.
Yeah.
So you have all the people living inside Earth, but then, of course, there's, all the class system and politics and all this stuff happens. Then you have, like...
Even as chuds, we still can't figure it out. Okay.
And then you have, like, the lower caste people who have to keep going up to the surface of the Earth to make sure everything's okay. Yeah. And, chaos ensues and all this stuff. But it's a pretty fun movie if you want to check out.
You can't open up that boulder?
Yeah, exactly. And I know there's parts where, like, one of the jets or whatever stops working, and they're like, oh, my God, we're going to die. All right, that's it for the show. I want to thank everybody for listening and calling in. We'll be back again next weekend, every Saturday, 6 to 7 p.m. right here on WCPT Age 20 Think Theory Radio.
From the heart of Chicago, it's WCPT 820. Progressive Talk Radio, where facts matter and voices fight for change. WCPT 820.
Would it be crazy if you packed your bags and left? For a week, a month, a year. What if you left for 2 years? What if you were going far away to help in a village on the edge of the Gobi Desert? To teach children and learn a thing or